before he leaves with the load, he fills his gas tank up on both trips. But 100 gallons is not enough to get all the way to Portland, so he has to refuel somewhere along the way, and he can't find a gas station. Which load will go farther before he runs out of gas, the 10,000 or the 15,000, Jake?
10,000.
10,000 will go farther, right? So there are a lot of economic concepts involved with this law of physics that affect your life. Here's another one. Raise your hand if you've ever noticed that it costs more to send a package that weighs 5 pounds through the post office than one that weighs 1 pound. Have you ever noticed that? Who can explain why? Why? Emily?
Because if it weighs more, then there's more friction.
Yeah, and it takes more gas, and the post office isn't in the business to not make a profit. Okay, now your one package might not make all that difference, but suppose that the truck's carrying 1,000 packages, and if they all weigh 5 pounds, it's going to take a lot more gas than if they all weigh 1 pound. So there are a lot of practical applications of this whole concept that you should know about. Let's see if there's anything else I need to tell you. Does anybody have any? Oh, who can name the manipulated variable in this experiment in one word? One word, Jackie or Jessica.
Weight.
Weight is a manipulated variable. Who can name one controlled variable? There's several of them. Who can name one of them? Name one, Jeremy.
Sinkers?
Huh?
Sinkers?
Yeah, the sinkers are all the same weight. Okay. What's another controlled variable, Chase?
Distance.
No, distance isn't controlled. Darby? Something that was the same for all of the trials.
The truck was the same.
The what?
The truck was
Yeah, same acceleration vehicle. What else was the same, Jake?
the acceleration.
The acceleration table. One more really important thing that was the same for all of them, Tanner.
The rubber band.
Rubber band. Okay. All right. Now suppose that I had used a different rubber band for each trial. Why would that invalidate the experiment? Why would that make the experiment useless, Darby?
Because you would have two manipulated.
You'd have two manipulated variables. Who can tell the class why you only want one manipulated variable in any scientific experiment? Nathan, why?
Because if you have two, you don't know which one is causing the
You don't know which one's causing the result. The primary purpose of all scientific experiments is to identify the result of applying the manipulated variable. Okay, that's the end of this focus. The focus today is called the crystal. The problem is, why are there no crystals in A, a few crystals in B, and a lot of crystals in C? Okay, I have 3 bowls up here. I'm going to show you C first because it has the most crystals. All that white material is crystals. B has a few smaller crystals. And A doesn't have any crystals. Maybe you don't know what a crystal is, so I'm going to show you a crystal I found up in the Cascade Mountains. I found this up by Snoqualmie Pass. It's the biggest crystal I've ever found. It's fairly easy to find crystals up in the mountains, and I'll tell you how to do it. Go up to a mountain stream. Well, you could even go to the Nisqually River if you can find a place where there's not a lot of sand and there's small gravel. Take a garden weeder, one of those things you scratch the weeds with in the garden, and go on during August or September when the river's really low or the creek's really low, and scratch around in the gravel next to the water line. And you can almost always find crystals, but they're a lot smaller than this. This kind of crystal forms when lava cools, but only when it cools slowly. The slower lava cools, the bigger the crystals are. And when you see those videos on TV of lava flowing down the sides of the volcano in Hawaii into the seawater, that cools so quickly when it hits the seawater that it doesn't form crystals like this. So this came from lava that cooled quite slowly. What you know?
It's like quartz.
What?
It looks like quartz. I have a quartz.
Yeah, it might be. Might be. What do you want, Wyatt?
I was gonna say that my grandpa goes volcanic and looks for crystals and
Oh
stuff.
yeah, he
out
probably
in the
finds a
mountains.
lot of crystals.
Yeah, and
Yeah.
that's pretty much what he does.
What, Nathan?
My aunt, she found a crystal about that big
Oh yeah.
somewhere.
Right,
She gave
right.
it to me.
Right. Well, some people spend a lot of time looking for crystals. Brandon?
Before my grandmother died, she found a lot of crystals and a lot of rocks. If
Okay.
you go down in our TV room, you'll find a whole shelf full of them.
Oh, good. Megan?
I found a couple crystals before down at the Nisqually River.
Okay. Now, the crystals in these bowls did not come from cooling lava. They come from another way that crystals are formed. Okay, now I'll show them to you again. C has the most crystals. All that white material is crystals. If you looked at them under a microscope, they'd look like the crystal I showed you, but they're a lot smaller. These are even smaller and fewer of them than D. And A has no crystals. Okay, I'm going to give you some data to start with. I started with 3 empty, clean bowls like this. Just like this, so that's a control variable. Now obviously I did something different to the 3 bowls to end up with those 3 different results. So, if you have a data question that might lead to an answer for why there are no crystals in A, a few crystals in B, a lot of crystals in C. Anybody have a question about how I might have treated those bowls between the time of the start and now? What do you want to know, Wyatt?
Did you put the crystals on them?
1, did you put crystals in any of the bowls? No, I didn't. I didn't put crystals in any of them. Okay. What do you want to know, Tanner?
Did you put hot water in C and like cooler water in A and B?
Well, I'm going to modify that a little bit. Here's what I'm going to say. Did you put some, underline the word some, kind of water in A? Yes. Okay, control question number 1. Did you put some kind of water in B? Yes. Next control question. Did you put some kind of water in C? Yes. I put some kind of water in all 3, so water is a control variable. What do you think the manipulated variable is? Somebody ought to get a hint at this point about what the manipulated variable might be. What, Emily?
If it was hot, warm, or cold,
Well,
the temperatures.
the water must have been different, right? She's suggesting that the water was different. Maybe it was temperature, maybe it was something else. But I'm gonna translate her question in this form. Did you put a different kind of water in each one? Now, the fact that I underlined the word some should have told you that the answer to this will be yes. A different kind of water in each one. Well, let's go back to Emily's question. Were they all the same temperature? Yes. So temperature is not the manipulated variable. How else could they have been different besides temperature? What do you think, Emily?
Was the water in the bowl the same amount of time as
Was the water in all three bowls for the same amount of time? Yes. Now, before these two questions were asked, for all you knew, the manipulated variable was the temperature or the time, but those weren't the manipulated variables. Okay, I'm gonna go back up here where I can write better and you can see better. 8. How else might they have been different if it wasn't by temperature or amount of time, Jessica?
Did you put any other kind of liquids in it? In the bowls?
No, just, well, only water in all three. Some kind of water in all three. Phoebe,
Did you put C in sunlight?
in the sunlight? No. No, they were all in the same place. During the whole experiment, if one was in one place, the other two were in that place too. They were never in different places. Okay, Emily.
Did you put sugar and C?
Not sugar, but I'm going to modify that again. Did you put blank water in a? Yes. 9. Did you put blank water in B? Yes. 10. Did you put blank water in C? Yes. Okay, now here's a big clue. A different word goes on each blank. Each kind of water was different. Each blank has a different kind of water. Now, since you know that, I'm going to show them to you again. No crystals in A.
No.
Nothing in A. Okay. A few crystals, small crystals in B, and a lot of larger crystals in C. All right? So we have 3 different kinds of water. Now, I'm going to start with C because it has the biggest and the most crystals. Who thinks they know what kind of water might have been in C? Janelle.
salt water?
Where would you go to get salt water, Janelle?
The ocean.
Okay, that's seawater. See, there's a difference between seawater and salt water. Salt water you can make by putting salt in water. To get seawater, you have to go to the ocean. I went down to Point Defiance Park, Orange Beach, and dipped out a quart of water, and I put 2 cups of it in here. Okay, so that was seawater. Now, I'm going to go down to 11 before we answer 8 and 9. Did the water from all 3?
Oh.
Yes. Now, it's a word that has that many blanks. Obviously, the water disappeared. What's the word to describe what the water did to disappear, Brandon?
Vanish.
Huh?
Or it I don't really
Chase,
Evaporated.
did the water evaporate? When a liquid changes to a gas, it evaporates. Yes, the water evaporated from all three. All right, so let's go back to C again. The water that was in here evaporated. Where did the crystals come from? Who thinks they know where the crystals came from? Jeremy?
From the salt in the sea.
These are sea salt crystals. There was that much sea salt in 2 cups of seawater. A lot of salt, but it's salt's plural. There's more than one kind of salt in seawater, and I'll give you a list of them later. Okay, so here's another thing that you should know. When, I'm giving you this, when water evaporates, is anything that is dissolved in it left behind? Yes. I'm giving you that bit of data. Now that's an important thing to know. When water evaporates, anything that's dissolved in it is left behind. All right? So this was seawater with sea salt dissolved in it. When it evaporates, the sea salt was left behind in the form of crystals. Okay, now, remembering what I just told you, when water evaporates, anything that was dissolved in is left behind? Well, what does that tell you about the water that was in this bowl? There were 2 cups of water in this bowl too. What does that tell you about the water, Stevie? What do you know about the water by looking at the bowl? It didn't have anything in it. It didn't have anything in it. It was pure water. Now, not many kinds of water you can buy in the store are pure water. Does anybody know what the one is called that is absolutely pure? Anybody know? What do you think, Allie? No? Tap water is not pure water. Janelle?
Pure out.
No. Brandon?
Sparklets.
No. This is what it's called. This is what the water's called that's pure, and it's the only one on the shelves of the store that you can be as sure is absolutely clear. Well, I'm going to write it one letter at a time. If your word fits, say it. D, I, S, T, I, L, L, E, D. Raise your hand if you've ever heard the term distilled water.
Oh, I got it right.
Distilled water is absolutely pure water.